Okay, so I want to go through some of the Cisco UCS prerequisites to properly support an NSX deployment. One of the things that I'm going to look at here is the QoS system class, which I already have configured. We want to make sure that you enable the proper QoS, map it accordingly, and we set a minimum bandwidth weighting for each of them. The other thing to look at here is the MTU of 1600. It's only really needed for the best effort class, but in the event that you change something within VMware in the future, you don't have to go back and mess around with anything. So here, it's better just to set the MTU to 1600. And VMware Network I/O control is going to actually mark traffic at the source host. So this is what's going to determine which traffic class that traffic is going to be classified into. The next thing you want to create is a QoS policy. So I already have a QoS policy here created. It's called NSX VDS marking. We want VMware, the virtual distributed switch, to be responsible for marking all QoS traffic. And if we don't do this, then the default behavior would be for the UCS host to ignore and delete the QoS markings. We also want to configure our VLANs that we're going to need for mapping the virtual distributed switch port groups. So you're going to notice here that I have a number of different VLANs, but the VLANs of interest for our implementation are the VLAN DMZ, which maps to 120, the two Edge VLANs 300 and 301. We have VLAN Management 100. We have the VXLAN VLAN 200, and we have VLAN 110, which is VLAN VMotion. What we created also was VLAN groups. So the NSX ACI demo VLAN group has the respective VLANs that we need for our demonstration here. So the VLANs are grouped into this VLAN group. We also want to make sure we have our MAC pools. So the MAC pools that I'm working with here are Fabric VNIC 4 and 5. So these are custom MAC pools that are going to be configured for each virtual NIC within UCS. And the assumption here is that VNIC 1, or here is VNIC 4, will connect to Fabric A, and then VNIC 5 is going to connect to Fabric B. Another thing that we need to focus on is the network control policy for CDP, which is right here. So the default policy, as you can see here, has CDP disabled. What we're going to want to make sure is that we have CDP enabled. Now let's take a look at our VNIC templates here. So for our VNIC templates, we're going to be using VNIC template 4 and 5 for our demo. So basically in this VNIC template, we have VNIC for Fabric A. You're going to notice here we don't have Fabric failover enabled. So this is going to be for Fabric A. We're specifying the MTU of 1600. Here's that MAC pool that I was talking about. Here's the QoS policy, that VDS marking policy. Here's that network control policy for CDP enable. And then as far as our VLANs, here are the VLANs that are specified for this VNIC template: DMZ, Edge 1, Edge 2, Management, VXLAN Transport, and VMotion. Same goes for VNIC 5, similar settings and similar VLANs. Let's take a look at our service profile template. So under servers, we created a service template, and this service template, pretty straightforward, kind of touches on what we just discussed. We have our, we're using the fiber channel storage here, configured by my peers on the storage team. And here are the two VNICs that will be presented with all the relevant VLANs. These templates are tied to the 5 blades that were prepared for me here, NSX ACI demo 01 through 05. Okay. Making sure everything matches correctly based on the templates. And then what we also have is our port channels. So we've configured port channels from Fabric A here. So we have our port channels configured from Fabric Interconnect A on port 19 and 20. These are the dual home connections that go into our Nexus switches. Same thing for Fabric B, 19 and 20. So that's pretty much it from the network requirements from UCS. Those are the things that I would stress to make sure that they're configured correctly. And since this is already configured for me with these settings, we have ESX already running on each of these blades, these 5 blades that were provided. We're one step ahead of the game here. So you see here that these blades, I'm showing KVM access to one of the blades, NSX ACI Demo 01. We already have an NSX, I'm sorry, an ESX implementation here. These blades are configured with ESX. And I also went a couple steps ahead and configured vCenter. Let me go here real quick. All right, so let me just log into vCenter here. And let me go through some of the things that I already prepared for this demo ahead of time. So I created 2 clusters, one for the compute, one for the management and edge as per the design. Disregard the faults here. This is basically indicating the default password for root has not been changed, so it's nothing to worry about. What I also performed here is configured HA and DRS. So distributed resource scheduler is enabled. HA is enabled. I also configured EVC because actually for this demo I have different CPUs per blade, so I enabled EVC. I don't have anything on the groups or rules, but I will configure anti-affinity rules later when I want to stick the certain virtual machines from NSX to each blade. So we're going to go into that in a little bit. What I've also done is I've installed NSX Manager, just a plain vanilla installation. We're going to go through the actual configuration of everything. But based on the network diagram here, as you can see, I'm using Management VLAN 100, the 172.32.0/24 subnet. I have vCenter on .100 and NSX Manager on 102. And these 5 blades that I'm showing you here across these 2 clusters are IP'd at 110 to 114. What I've also prepared is vMotion, the port group for vMotion. So going back in here, under networking, I created that VDS main that we designed. I have it in a different picture. Here's that VDS main that we were talking about. We have that single virtual distributed switch and the port groups. So I already configured management and the vMotion, and vMotion is already configured in multi-NIC because I needed to move some virtual machines around to prepare for this demo. So to go kind of back here, I have my management port group where all these particular systems will be on. And then I have my vMotion VLAN 110. And for vMotion, I'm using 10.250.252.0/24. So what that looks like is right here. I configured my VLAN 110 for vMotion. And as far as the active uplink, the teaming and failover policy, we have here, we have vMotion 1 is going to be active standby, active on VMNIC 0 and standby on VMNIC 1, and vMotion 2 is going to be standby on VMNIC 0 and active on VMNIC 1. So to make sure here on vMotion 1, we have the uplink 1 as active and uplink 2 as standby. And on vMotion 2, we have uplink 2 as active and uplink 1 as standby, and everything is routing based on original port ID. And as far as management, you notice that I'm going to use VLAN 100. With respect to vMotion, we just kind of go through the settings here. So for vMotion, I created those two VM kernel ports, and they're using the vMotion stack. They're both on VLAN 110, and they have IP addresses that are part of the same subnet. And kind of going back here real quick, these are the two VM NICs that were mapped to the VNICs that are provisioned by UCS. So they have that one-to-one mapping. And for our TCP configuration, TCP/IP configuration, I added that gateway address to vMotion for layer 3 vMotion. So basically what I did here was just configure the same, pretty much the same settings across all of the compute and management and edge blades. Obviously they're using different IP addressing, but it's the same, pretty much the same design. One thing that I want to do is I want to add these additional port groups into the VDS to prepare the vSphere, the remaining vSphere requirements for NSX. So what I'm going to do right now is, since management and vMotion is already configured, I'm going to configure the Edge port group 1 and port group 2, the DMZ trunk, and then the VXLAN. So I got to do Edge port group 1. And we're using VLAN 300 here. And let me create Edge port group 2. using VLAN 301. We also want DMZ, DMZ trunk, and VXLAN. DMZ is going to be 120. Oops. DMZ trunk. We need to specify a VLAN here. And the VXLAN it's gonna be automatically generated when we configure within NSX, within the NSX portion. So what I want to do now is I want to configure my QoS. As I mentioned before, the virtual distributed switch is going to be doing the marking. So I want to make sure VMotion gets the bronze class with a COS of 1. So I'm just going to go into VMotion here and edit the settings and enable traffic filtering and marking. And I'm just going to basically do VMotion QoS. And I'm going to tag COS 1. I'm going to apply that to the system traffic qualifier for VMotion. Here it is. Okay, and I'm going to do that for the other VMotion as well. Alright, so QoS is set up for VMotion. Now I want to do management. There we go. And management QoS is going to get a COS of 2. And let's do an IP qualifier of anything. So basically anything that's coming in on the management port group is going to have, any traffic that's coming into the management port group is going to have a COS of 2, which is the silver class, I believe I said in UCS. Edge routing. So edge routing, we're going to set it to 0, which basically maps to best effort. And we're going to basically say the same thing, any traffic. So when the VXLAN port group gets created, we're going to do the same thing. Let me just set DMZ here. To best effort. Okay. All right, so what we also want to do here is we want to set the MTU to 1600 on the BDS. And I think that's pretty much it that we need to do for now here within vSphere. Let me think here. So, as I mentioned before, I pre-configured, or actually I installed NSX Manager. Let me jump into that instance real quick. And I already configured it, so just single sign-on. No, all right. So what I've got configured here, what I did was NTP obviously is very important. All the systems just point to the public NTP services. Networking, gave it the IP address, the default gateway, the primary DNS server. DNS records are important here, along with reverse PTRs, so that NSX can reach vCenter and all the ESX hosts. Everything can resolve to the proper IP, the name to IP. And here you go. So I also configured the lookup service, basically pointing at vCenter. vCenter in this installation is the appliance, and obviously I connected to vCenter. So all of that is up and operational. So when I install NSX Manager, what I get is this nice new tab for networking and security. What I want to do first is I want to create my IP pools. And actually, I actually already created them. So I have a controller pool that I created, basically the 172.30, 32.107 through 109, default gateway 32.254. So what that represents is this pool of IPs that I'm going to be assigning to each NSX controller, 107 and 109, so 107 through 109. And I also created my VTEP pool, and this is basically the different VTEP IPs that I'm allowing my ESX hosts to use for the VXLAN transport. So I just gave it a pool in the 10.250.254 subnet here, and that subnet is basically this VXLAN transport VLAN 200. Okay. And we're going to have an active design with our virtual NICs. So we're going to have 2 VTEP IPs per ESX host. All right, so for some reason I thought I didn't handle this already previously, but these are already configured for me, or actually I configured them earlier. So we're going to use them in our configuration. So what we need to do now is actually deploy the cluster, the controller cluster, to each of the hosts. So I'm just going to deploy the NSX controllers. I'm going to call this NSX Controller 1. Manager Data Center Pool. This is going to go into the Management and Edge. And I'm going to put it onto the Data Store 01. I'm going to specify here that it's actually going to connect to Management. And the IP pool is going to be that controller IP pool that I showed you a couple minutes ago. was weird. And we got to give it a password. All right, so we're just going to give it a couple minutes here to finish deploying. And I'm going to pause the video while it's doing that. Okay, so the first controller finished. I'm just going to add another controller here. I'll also put on the management and edge. And I'm not going to worry about which blade or which server in that management and edge cluster the controller is going to get deployed to, because later on I'm going to vMotion them around accordingly, and I'm going to set up anti-affinity rules to make sure they stick to where they're supposed to be. Okay, and then I'm going to deploy the third and last NSX controller. NSX controller 3. Alright, so I got my NSX controllers installed. Let me do one quick thing and go on the NSX Manager, and I need to make sure that I'm excluding vCenter. I'm going to add vCenter here to the exclusion list. Okay. I want to go back to my configuration. I'm going to go into the host preparation now and prep the hosts. Alright, so this host is prepped, actually cluster, and when I do this, it's automatically going to configure it for all the hosts inside the cluster. So I'm prepping the management and edge cluster, and that one consists of these 3 hosts. Alright, so firewall is enabled. Let's get VXLAN configured here. Our switch is VDS main, and we're going to use VLAN. Let me go back here. VLAN 200 for VXLAN. So I'm going to punch that in here. MTU of 1600. My VMK NIC IP addressing, if you remember, I have that VTEP IP pool. And we're going to set this to load balance source ID, so it's going to configure 2 VTEPs. Okay. So let me go into logical network preparation. We're going to have to configure the segment ID. So already configured that, 5000 to 5099. So here are the segment IDs, 5000 through 59999. The multicast address, I just picked this out of the blue. 239.0.100.1 through .254. And these are the multicast addresses that are going to be used per the logical switch. And transport zone, let me just create one real quick. Let's call it TZ main. And this is where we're going to specify our hybrid mode. And we're going to specify it for both of our clusters. All right, let's configure our logical switches now. And let me go back here to the diagram. Not this one. So what we're going to need is the transit logical switch, the corporate logical switch, the app logical switch, the database logical switch, the DMZ logical switch. Because we're going to be doing a trunk interface here, we're going to need to configure HA between the DMZ edges. So we're going to create a separate logical switch for that DMZ edge interconnectivity, because in order for HA, it requires an internal link. So this, I don't believe, is going to qualify as an internal link for HA reasons. So we're going to create a separate HA logical switch for these guys so they could talk their HA language. Also, for the DLR control VM, we're going to configure an HA network in between these DLR control VMs. So let me configure those two HA switches, and then I'm going to configure the transit, corp, app, DB, and DMZ. And let's do corporate. NSX DMZ. App. DB. And transit. All right, so let's deploy the DLR and DLR control VM first. We're going to go under edges. So we're going to do the logical distributed router. Yeah, that's fine. We're going to just keep it like that. We're going to configure HA. That's fine. Put some password here. And we're going to enable SSH access. We're going to pop this into the management and edge. And I'm going to use the data store that we're using for other devices. Now, again, I'm not going to worry about what host it chooses for now, but because we're going to change that later anyway. So the HA configuration here, as I mentioned before, is I'm going to use a logical switch, and I'm going to use that NSX DLR control VM HA so that they could exchange their heartbeats and stuff, and keep alives. And I'm going to add some interfaces. So let me go back to this diagram here. So we're going to need to configure all of these interfaces. So let's start with the transit link. I'm just going to keep it simple, transit interface. That's my uplink, and it's going to be connected to my NSX transit logical switch. And we have to configure our subnets. So we're using 10.251.5.0, and I'm on the .1. and I gotta do 10, 251, 10, 20, and 30. I'm configuring this device right here. So we do the corporate. It's going to be an internal connection. And I'm going to connect to the corporate logical switch. Now let's do the subnet here. Got 1. That's also /24. Let's do the app interface. App, and the word interface is not too sexy, but just keeping it simple here. This guy's going to be .20.1. So specifying the default gateways pretty much for all of our virtual machines at this point. Transit is a little bit different as to connectivity, so it could talk to the different edges. And DB. And database obviously is connected to the database. All right. So there's my DLR. I believe I have everything taken care of. This interface, okay, so 4 interfaces in total. I'm not going to configure a default gateway here for now. I'm going to leave that alone. And here's my summary. Transit is 5, 10 is corporate, 20 is app, 30 is DB. 10, 20, 30, transit is 5. Okay. So let this deploy. Alright, so it finished installing. And what basically happened here is that DLR configured 2 instances, right? Because we configured HA. So there's the active and there's the standby. And we're going to configure it a little bit later. Let me just get the edges deployed first, and then we're going to do all of our routing, configuration, BGP, etc., etc. Alright, so we have our HA DLR control VM, or DLR, configured. Now let's do both of the Edge 01 and Edge 02. So we're going to specify Edge Services Gateway here. And we're not going to do high availability. We're going to do high availability actually for the DMZ, but this one's going to be configured in ECMP mode, so there's going to be no HA deployment here. And for the sake of the demo, I'm just going to keep it compact. I'm going to also deploy it on the management and Edge. And let's get the interfaces configured. So, starting with Edge 01, we have to configure this uplink interface, which is going to be on VLAN 300, and then the downlink interface, which is going to be on Transit Transit LS 1051.5, and it's going to be .3. So VLAN 300 is going to be the 10 to 50 here. So let me just copy it. And we're .3. So let's do Edge 01 uplink VLAN 300, and we're going to select the distributed port group for Edge port group 1. That's strange. All right. So let's configure those that interface for VLAN 300. So we're going to be .3, and the subnet here is a /28. Let me confirm that. /28, yeah. We don't need a secondary IP address here. Everything else can be left the way it is. And let me configure that transit network. And that's going to be a /24. So transit interface. If I could spell right. So that's going to be an internal interface. And that is going to be on a logical switch here. Let's get our IP addressing going. So we are .3. And that is a /24. We don't need anything else here. So that looks good to me. We're going to not configure a default gateway. We're going to figure that whole piece out with routing. I'm going to just set it to an accept, but we're going to disable the firewall on these anyway. So all looks good so far. Let's let that deploy. All right, so that edge gateway deployed. Let me just take a look here real quick. Here it is, NSX Edge 01 on my management and edge cluster. So now let's just go back and configure the other edge. Oops. All right. Crap, what did I call that interface? I think it was just uplink VLAN 301, if I remember correctly. And we're going to be pointing it at Edge port group 2. Let's configure our IP space. So we're going to be different /28. We're going to be .19. Let's configure our transit interface. It's going to be an internal link connecting to our transit. And we're on the 10.5. We are .4 here, /24. Just want to make sure. 4, yep. All right. So, taking care of those interfaces, no default gateway, firewall policy. Again, we're going to disable it later, and let's wait for that to install. Okay. Let's also, so we basically configured the DLR, the 2 DLR control VMs, the 2 edge gateways. Let's configure the DMZ Edge gateway. That's also going to house the load balancer here. And then after we do that, we're going to configure, we're also going to deploy this edge load balancer. So let's do the edge gateways first. we're just going to call this DMZ Edge. And we're going to configure this for high availability. So my interfaces, let's take a look at what that's going to look like here. So let's configure this particular interface first for the transit LS. And that's going to be .11. We're going to consider that an uplink. NSX transit. And we got to get our IP, so we are .11 on the 5 subnet. Okay. Then let's configure our secondary uplink interface. This is going to be this DMZ, so it's going to be a VLAN backed and not a VXLAN backed. And we're .11 here as well, so 10.255.120. So we're going to go to that DMZ port group that we defined previously and mapped it to VLAN 120. And we're .11, and that's a /24. Yeah. Okay, looks good. All right, now what we're going to configure is this trunk interface. It's going to be an internal interface. Actually, I don't believe we're going to be able to configure it here. So we have to deploy it, and then we're going to configure it. So we're going to just configure it with these two interfaces for now, and then we're going to go back and we're going to configure the rest. So again, we're also not going to configure a default gateway here. And here's that that HA configuration. So let's put 192.168.100.1, 168.100.2. So our HA is actually going to fail, and we're going to fix that when we do the. Actually, let me take that back. Let me go back here, and let me add our HA interface. So DMZ Edge HA interface, and we need an internal link for the HA interface. So let's do that here. DMZ Edge HA. That's going to be our transit, and we're not going to put any IP address because this is the IP address that's going to be used over that link. So let me deploy that. Alright, so it installed. I'm going to just go back in here and configure it accordingly for that trunk interface. So I'm just going to go here, pick a VNIC, edit it, and I'm going to select the trunk interface here, DMZ trunk, and that's going to be connected to that DMZ trunk distributed port group that I created before. And this is where I'm going to specify my sub interfaces. So what are we looking at here? We got DMZ interface. So DMZ, web interface. Pick a tunnel ID. Let's do 1001. It's going to be a network backing type, and the network here is that distributed. I'm sorry. Logical switch, DMZ. That's what it was. So we're basically backing with a DMZ logical switch that we created. So let's go to our subnets now and define IP address, which is going to be .1, and that's going to be on /24. 10.255 1.1, and that's going to be on /24. And we're also going to be configuring a VIP, so I'm just going to add that right now as a secondary IP address. So we're going to use 10.255.1.5 as our VIP for the load balancer, so I'm going to just pre-configure all that right now. So everything else looks good. Configure that interface. And let's go back, because I want to get that other load balancer deployed. Right now we have these configured in an HA, so we want to configure these in an HA as well. And for these, we're not going to need an HA interconnect because they're going to use the internal interface, which is that corporate LS here. So we're going to do HA here as well. What are we calling this? Internal load balancer. So NSX internal LB. I love these complex passwords that you need to put in here. We're going to keep it as compact. You would most likely size it accordingly, but for the sake of this demo, we're going to keep it simple. So for the interfaces, we're just going to create one interface, and that's an internal interface. It's going to be this. It's going to be .5 on this corporate logical switch. And this is the logical switch here, corporate. We're going to give it an IP address. It's going to be .5 on /24. And that is also going to be our VIP, because this is going to be our load balancer that we're deploying right now. So we are going to configure a default gateway. That's going to be our corporate interface, and that's going to actually be the DLR. So we're going to do the 10.251.10.1. That's going to be our DLR. I'm not going to do any special routing here. Firewall policy, and we're going to use the internal VNIC. So we're also going to do 192.168.101.1. 2. Alright, so let me just check here and make sure HA is configured properly. So if I go to settings, configuration, I should see high availability. So high availability is up. So we know that it's communicating correctly. Let me check the load balancer here. High availability is up as well. So we're good to go for now with the HA setup. Now let's configure all of our devices. So let's start off with the first one, which is the DLR. And the DLR is going to have a BGP peering with Edge 01, a BGP peering with Edge 02, and a BGP peering with the DMZ. So the BGP AS that we're going to use for the DLR, and this could be iBGP, but I'm doing eBGP because I want to have the flexibility of being able to match on specific AS down the line inside the data center network as BGP updates come in from inside the data center and maybe propagate down the line somewhere, and I want to make a routing decision so I can easily match on AS and cover all the IP subnets that come from that AS, right? So I have a lot more flexibility. Yes, I could do OSPF, or I could do static routing, but I want to do BGP for this particular video. So we're going to use AS65251 for our DLR, and it's going to advertise as locally connected networks into BGP, and all of my BGP peers are going to learn about it. So let's configure .3, .4, and .11 as BGP peers. So we're going to go into the NSX DLR here. Just going to disable the firewall. Do I need to disable the firewall? Technically, I could leave it on. I don't think it's going to really matter. We'll just keep it on. Although, yeah, let's turn it off for now. What we need to do is we need to enable routing. So this is going to be an ECMP setup. Because we want this DLR to be able to see both edge gateways. Well, not see, but be able to forward traffic to both edge gateways for the same subnet. So if the internal data center network is advertising some subnet through the edges, I want the DLR to choose either edge 1 or edge 2 for that particular traffic flow. So we're going to enable ECMP here. And we have to configure our dynamic routing configuration. So let's use our router ID as our transit interface. And we're going to jump into BGP. We're going to enable BGP, and we're going to set that local AS to 65251. Oops, should have configured the neighbors. Let me just configure the neighbors real quick. So, oops. We got 3, 4, and 11. So neighbor 3 and 4 are going to be on 65250. So my forwarding address is going to be actually my DLR IP address, right? So I have to specify 251.5.1, but my protocol address is going to be .2 because there's a control plane, data plane separation. So it's a little wacky if you're kind of comparing it to traditional networking. So remote AS was 65250. Yep. We're going to change the timers here to 3 and 10. Password, we could put a password, but we're not going to worry about password right now. We don't have to do really anything with BGP filters. We are going to do BGP filters on the DMZ. So stay tuned for that. And so we got to do the same thing for Edge 02. 250. Password 65,250. Looks good. And .11, which is the DMZ Edge. And that AS is 65,255. All right. So I have my neighbors defined. Let me go into route redistribution. We're going to do route redistribution for BGP. And we're going to, what is this? This is just a default setting. We're going to redistribute our connected networks into BGP. All right. So that's pretty much it for the configuration here on the DLR. We have our ECMP enabled, so it could actually choose both edges for the same network. We have our router ID set up. We have BGP enabled. We got the AS specified. We got our neighbors, our keep alives and hold down timers, and we're this didn't go through for some reason. That's why it's always good to check your work, even though you think you have it configured. All right, so we're in good shape here. Let's move on to the next one. Let's go to Edge 01. Interfaces. Wait a minute here. What's going on here? This is not right. I'm not sure why we have those interfaces. Yeah, I must have messed something up here. It's not right. Yeah. DMZ Edge. Maybe I clicked on the wrong one. Okay, so this is what DMZ Edge should look like. But I thought I clicked on Edge 01. Okay, so it's just, that's weird again. Just a refresh. So Edge 01, this is what it's supposed to look like. Scared me for a second. All right, so Edge 01, we're definitely going to be disabling the firewall here. This traffic is going to be flowing through both edges. And as far as routing, we're also going to configure ECMP mode here. Router ID, we'll use that uplink VLAN. That's weird. Might be a refresh issue. Let's come back to this because this should have BGP enabled. Or actually, I might have to enable it here. So Edge is going to be 6520. 65250. What am I saying? 6520. 65250. And specify our neighbors. So our neighbors are going to be .1, and .2 is actually here, just it disappeared for some reason. Maybe I deleted it by accident. So it's 1 and 2 are my neighbors on VLAN 300. Remote AS is 65,000. And I gotta talk to my transit. So 65251. Actually, I'm going to be pairing with the DLR control VM to be specifying .2 and not .1. This is 65251. And lastly, the DMZ Edge, which was 65255. Okay. Let's publish those changes. And I want to redistribute my connected networks, which are basically the links on VLAN 300, because the transit one is going to be run by all the devices regardless, because it's directly connected. So I'm going to advertise those networks. Okay. So just to confirm everything, ECMP is enabled, BGP is enabled, we have our router ID set. This Edge 01 is using 65250 as the AS. We have our 4 neighbors defined. We're not going to be configuring Edge 1 and Edge 2, peering, IBGP peering. It makes no sense in this particular design. So we got the 2 core switches, 250.1 and .2. We have our DLR control VM, and then we have our DMZ Edge. And we're redistributing our connected interfaces. So Edge 01 looks looks good to go. Let me go to Edge number 2 and configure the same. So Edge number 2 is using 17 and 18 for peers. Now the DLR control VM. And the DMZ Edge. Looks good here. Okay, let me just double check my work here. ECMP is enabled. I'm running BGP as my router ID. BGP is running on 65.250. I got my neighbors, my core switches, my DLR control VM, and my edge. And I'm redistributing. So these edges should be good. Now let's do the last one, which is the DMZ Edge. Firewall will keep on because it's a HA setup. We're not doing anything crazy with ECMP. We're not worried about asymmetrical flows. So we're going to keep ECMP. Oh, actually, we're going to enable ECMP because I want to be able to use both edges. It's kind of like how the DLR is going to be, right? I want to use both edges to get to the internal network. So I'm going to use my transit interface as my router ID. And I am 65.255, that's my AS, and my neighbors. So my neighbors, let's do the hardware firewall here, the routing process on the hardware firewall, which is .1. And this is going to be an IBGP connection, right? So this is a 65.255, same AS. So this is going to be IBGP. And I want to do some filtering here. So because I want this traffic pattern to conform accordingly, where external users come in through the hardware firewall, they get dumped directly over the DMZ and not the internal network, right? So they're going to come in over the DMZ into the edge uplink here to service this active VIP. I want to make sure that the DMZ routes are not being learned from the internal network. So in order to do that, I have to set up filters. I basically have to filter out anything that I have other than the 10.255/16 network. I can't advertise anything other than that to the hardware as well as to the edges or the DLRs. If I do, I'm going to create some funky routing, inefficient routing flows. So I'm making sure that DMZ only advertises its own networks and he does not become a transit. So the way I'm going to do that is I'm going to summarize this 10.255 segment into a /16, and I'm only going to advertise those routes, that /16 to the hardware and to the internal network. So let's do that real quick. So this is to the firewall. So in the out direction, I'm going to basically say 10.255.00/16. I'm going to do a greater than 16 and less than 32, and that's the only thing I'm going to allow to advertise. And then I'm going to basically say deny anything else. So those are my configurations for towards this this Internet Edge firewall. So now let's configure the edges and the DLRs, and I'm going to basically take the same approach here with those filters. So I'm denying anything else. But I'm actually learning, just to kind of mention that I'm learning everything because I want to make sure that traffic returns accordingly to both the outside and the internal network. All right, so there's our configuration for routing, and I'm going to test everything in a minute. Let me just do a sanity check here. All right. So let me check all my routing. I'm going to go to the actual host itself, the virtual machines itself. There's my DLR. All right, that's not a good sign. Let me check something here. All right, so I basically logged into the passive one. So here's the active one. Let me just see something here real quick. All right, yeah, this one's the active. So here's my IPBGP table. What's happening here is I'm learning the 10.250.250.0 subnet from the two edges, as you see here. I have my locally connected networks, the transit, and I'm learning 10.255.120.0 from the edge. So if I see the networks that I'm actually entering into my routing table, here they are. So routing here is going to be good. We got to check on the default route. The default route should be propagated from the internal network. So I want to check on that. Leave this open. Let me log into Edge 1. What's going on here? Let me refresh the screen. All right, here we go. So let me get in here. Oh, I must have logged into the HA unit. Show service. Yeah, this is a standby. Oops. Kill this. There we go. All right. So DMZ Edge, I'm getting the default route from the firewall. Getting the 10.250.250 network from the edges. I got the routes from the DLR, the 10.251, 10, 20, 30. But what I'm not getting, so I have show IP BGP neighbor. I have connectivity to the DLR. This is the bottom one is the edge, and here's the firewall. So I have a established setting with the hardware firewall, established state. So I'm getting routes from there. So I'm in good shape for now, but I'm not getting any routes from the internal network. I gotta check the actual edges and see why those sessions are not coming up with the internal network. Yeah, they're not coming up. So show IP BGP neighbors. Yeah, it's an active state. So I gotta check to see what's going on. Why is it in active state? So let me log into that core there real quick. All right, so that's better. I just have to make the problem I had was I put the wrong AS number on the cores. It was actually set to something else, so I have to adjust the AS number to 65,000. So you're going to see now here under my neighbors, 10.251.52 is the DLR, 5.3 is, oh, this is DMZ Edge. Oops, wrong one. This is the guy I wanted to do this. BGP neighbors. Okay, well, I thought it was up. Alright, let me check that again. Alright, you know what? I kind of figure out, I think I figured out what the problem was. Why I'm having some weird connectivity issues, and it's going to come down to my teaming and failover, because I never set the actual teaming and failover policies, and I'm seeing that my edges are not coming up properly. So if I go back into my teaming policy here, this is one thing that I missed. For my edge port group, I have active and unused, and edge 2 is unused and active. So let me get that configured. This is one thing that I missed here. So edge port group 1 under the teaming failover, we have this guy unused. routing base port ID, and this guy should be uplink 1 unused. That was my original design, and I think that's why I'm having some quick the peering wasn't coming up. But let me also go into my DMZ here, make sure that I get that configured. So DMZ is standby active. And I'm going to check in a minute. So standby, there you go. Standby active. VXLAN is active, so we don't have to do anything. But I still have to remember to go back and do the QoS. VMotion's already configured. And DMZ, this one's already set that way, that's the default. So let me check to see if my peerings came back up. Yeah, so I could ping now. Before I wasn't able to ping. Okay, that was the problem. There we go. So now 10.250.250.1 is established. 250.250.2 is established. DLR and the edge. So if I do show IP route BGP, now I'm getting the default route. So you're going to see here that because I enabled ECMP, I'm getting the networks, the quad route, quad 0 route from both cores. And in this particular design, I'm doing routing over VPC. So equal cost multipath is definitely enabled. So this is what I was kind of looking for. And let me see here to confirm. Yeah. So the 10.250.254.0/24, as you see here, which is the fourth line number, that is this VXLAN transport VLAN. I was just doing that, using that as a test to make sure, because that's actually a VLAN that lives on the cores here, and the cores are advertising that. So each respective core is advertising that VLAN over VLAN 300, over 300 and 301. Those are my peering VLANs. So that was just a test to validate that that network's coming in, and then the edge firewall here is originating a default route, and that's propagating down through the core, through the cores into the edge gateways. So going back here, what I wanted to show is that if, for example, a packet comes into Edge 01, right, and it needs to go to the DLR network. For example, I'm right here, right? So if a packet comes in from the internal network into Edge 01, if it needs to go to the DLR, if it needs to go to, for example, the corporate network, the 10.251.10, it's going to go down into the DLR directly. And if it needs to go into the DMZ zone, then that packet is going to come into the edge, and the edge is going to punt it down into over the transit logical switch to the DMZ edge, where it's going to get serviced. And what we're also going to prove is that traffic from the DMZ or the internet is going to come in over the hardware firewall, and it's going to come over this transit link instead of going through the internal network, right? Because that's the routing policy that we want to make sure that that works. That it works that way. So we can see here that if traffic is going to the DMZ, the last route here. So if I do show IP route 120, or actually 1.0 network, you're going to notice that it's going to the 251.5.11, which is the DMZ edge. So that is as expected. And if we went to the edge here, and we did show IP route, if I'm going to the internal network, which, for example, is the 10.250.254.0, it's going to go to the edges, right? And it has a load balancing here, right? Because it has two routes for the same network. And if the edge now wants to respond back to the internet, let's check to see where the route for the internet is. You're going to notice that the 10.255.120.1 is actually the internet firewall. So we're pretty much, because of the BGP filters that we put in place, our routing is where it needs to be to make sure that, again, any traffic that comes from the external clients, from the internet, is going to come in over a hardware firewall, hit the DMZ interface, onto the DMZ transit VLAN 120, and then it's going to hit the DMZ Edge, and then be serviced on the web tier here. And then if any traffic comes in from the internal network to a WAN connection or some kind of connection that comes in on this internal network, it's not going to send it up northbound to the hardware firewall. It's going to send it southbound here into one of these edges, right? Because it's going to be load balanced, and then the edges are going to forward it to the DMZ Edge, and it will be serviced on the DMZ logical switch. So our routing policy is set. What do we still need to do? So we still need to configure the quick QoS on that VXLAN. So let's go to that VXLAN right here, and I'm gonna come in here, and I'm gonna set the VXLAN QoS. We're gonna basically tag it with a 0, so that's basically for all traffic. Okay, and we also have to set our anti-affinity rules. So let's do that real quick. I don't believe I'm missing anything else. Yeah, let's do our anti-affinity rules. So we should go to the cluster. I'm not going to worry about the application here. What's more important is actually these components. So what I want to do first is I want to configure my host groups. Let's do management blade 1, and we're going to do a host group, and we're going to basically point it at NSX 01. Do another group here. Blade 2. We're going to point it to blade 2. Blade 3. And so I got my host groups, and now I want to create my VM groups. So we'll do a group for prefer blade 1. And what are those VMs? So let's go back to my design here. And my design was that I want vCenter, the active DLR control VM, the active DMZ Edge. The clusters I'm not going to worry about because the anti-affinity rules that we're going to configure are going to separate them out since it's 3 and 3 blades. The internal load balancer, the active one, and Active Directory. So let's configure that real quick. So for blade 1, we're going to do vCenter, the active instance of the load balancer. Which one's the active? I think it was. Let me hold that thought here. Because we don't care which one's going to flip through later. We care about that now. So we know that the ones, the DLR 1 and Edge 1 here are active. So let me check here. Where's my, actually, you know what? Let me Let me go in through the host. Might be faster. I think I fat fingered the password. There you go. So this one's the active. So 0 is active in this case. All right. Beautiful. All right, so let's add those VM groups. So we got the active load balancer, we have vCenter, DLR control VM, DMZ Edge, and Active Directory. DMZ Edge 1, DC01, and the DLR control VMD active 1. It's 1, 2, 3, 5. 1, 2, 3, 4, 5. Yep. So these are the devices that I want to go onto Blade 1. And I'm going to create another VM group here called Prefer Blade 2. And in this case, I'm going to want the passive load balancer, Edge 01, and standby DLR control VM. So the passive DLR control VM is 0. Edge 01, and inner load balancer 1. And lastly, Edge 01, and NSX Manager. So, did I say Edge 01? Edge 02. NSX Manager. And, DMZ Edge passive. DMZ Edge. This one. Okay. All right, so those are my groups. Now let's go into the rules. So, there's rules that are going to be automatically configured when the edges are deployed. So these are basically making sure that the DLRs are on separate virtual machines. On different blades. This is basically so that the edges are Edge 1 and Edge 0 and 1 are on different blades, as well as the load balancers. So what we want to do also is it doesn't automatically configure the anti-affinity rules for the NSX controllers. So we're just going to want to do anti-affinity NSX controllers, right? So we want to say separate virtual machines, and we want to select all 3 controllers. So by adding this rule, that's going to push them to different blades. And because there's 3 blades, 1 per controller, it works perfectly. So what we also want to do is we want to configure those host rules. So we're going to just rename it again, the same name, Prefer Blade 1. We want to do virtual machines to hosts. So VM group Prefer Blade 1 is going to should, not must, but should run on management Blade 1. Okay? So by doing this, we're going to actually stick them to each, per the design, VM to Blade. So Blade 2 is going to talk to Blade 2, and it's going to be should, not must. I'll go through or no? And Blade 3 So that went through. So let's just give it a minute. Let's make sure all the virtual machines move around where they need to go. And then we're going to take a look at it. All right, so what do we say? Let's just do a quick spot check here. We want the active DMZ Edge, so in this case is DMZ 01 to be on blade 1. So DMZ 1 should be on blade 1, and it is, right, on 01. We also wanted Edge 01 to be on blade 2, so let's check that. Edge 01 is on blade 2. Last spot check, NSX Manager should be on blade 3. NSX Manager is on blade 3. There you go. So there you go with those anti-affinity rules to making sure that, you know, our design, these virtual machines pretty much are pinned to these blades, and obviously if there's a failure, HA is going to kick in. Those virtual machines are going to kick over to the next available blade. DRS is going to take over. All right, so let's configure our virtual machines. Let's test our 3-tier application. So let me make sure that the correct logical switches are set for these guys. So app 01 should be on the app logical switch. App 02 get database. And then our webs should go on the DMZ. Which I'm calling the DMZ here. Or the web tier. All right, so now our applications are connected in. These are the 5 applications that we have. We connected the webs to the DMZ logical switch, apps to the app logical switch, and the database to the database logical switch. The load balancer here is already on the corporate logical switch, so it's ready to go. But we need to configure our load balancers. So go back here. So let's configure the DMZ load balancer first and make sure that this VIP is operational. So we're going to have to go back to NSX and so let's do the DMZ Edge first. So I'm going to go to the load balancer and enable the load balancer. Configuring like load balancing is very, very straightforward. And what we're going to do here is we're going to create a new profile. We'll do load balance, call it DMZ, load balance, web here. And we're going to set that for HTTP. It's a web server. Nothing else. Let's keep it simple for now. And let's create some pools. So let's do a web pool. Round robin, let's do a default HTTP monitor, and let's add our members. So the virtual machines that we configured, oops. So here's the IP 1.10 and 1.11. So this is going to be web 01. .10. Port 80, and we're going to monitor on port 80. Web 02 is going to be .11, same thing, port 80. All right. And we have to, so we have the IP already configured. So let's go to the virtual server and let's configure our virtual server. So DMZ LB web tier. Yeah, let's just say VIP web tier. VIP DMZ web tier. The IP address would be that DMZ web interface. We're going to use the .5. So 10.255 1.5 is going to be our VIP, and that's when traffic hits that IP address on port 80, it's going to load balance to one of those web servers. And the pool here is going to be in that web pool that we defined, web 01 or web 02. We don't need anything special in application rules, so we're going to keep that simple. So that should be up and running now. Let me go configure the other load balancer. So again, we just configured this particular VIP.5. Any traffic from external or internal that hits that VIP on port 80, it's going to get load balanced to one of these web servers. What we have to configure now is that these web servers need to talk to the application servers, right? So they're going to be talking to this VIP, which is 10.251 10.5, right? We're doing a one-arm deployment here. So that traffic is going to come in, it's going to hit this VIP, and this VIP, this load balancer is going to load balance to one of the apps, right? So now let's make sure that .5 is configured for load balancing on the internal load balancer. So the internal load balancer is right here. Just double click it as well. Do the same thing. No magic here. Pretty straightforward. Enable load balancer. We're going to create our application profile. Load balance the app tier. We're going to do just regular HTTP as well. That's our 3-tier application. As far as our pool, app tier pool. Round robin is fine. We're going to do regular HTTP monitor, and we're going to specify app 01 and app 02. Let me think about this here. Yeah. So app 01 will be .10. Same thing, port 80. And app 02. Port 80 as well. And then let's configure our virtual server. App tier. and this is going to be the 10.5, basically the IP address of the load balancer. Going on 480, and we're going to load balance this app tier pool. That's pretty much it. So let's test this. Let's test that the application works. Let me log into a host real quick. So I logged into this host here, just to show what IP address it has. So it's on the 32 network, and basically what that is on the inside network. It's on the core. So I just want to just make sure I can ping here. There's the default gateway of the core. I want to make sure I can ping the VIP 10.255.1.5, and I got IP connectivity to the VIP. So all I need to do is just type in the IP address of that VIP, and that VIP is actually that DMZ. Oops, sorry. 10.255.1.5. So I should get a response here, and there it is. So here's our little 3-tier application. Basically, I'm here connected to the cloud. I hit the VIP. The VIP load balances to the web servers, and the web server hits the load balancer again, and then hits the app, and then the app talks to the database. So here's basically the server chain. We're using Web 01, App 1, and Database 1, and we're pulling, these records out of the database. So if I refresh this, I should take a different path. There you go. So right now, this load balancer just load balanced to Web 02 and went to App 01, and obviously to Database 01, which is not load balanced. So if I keep refreshing this page, you're going to notice that I'm getting some load balancing here. Right? There's some round-robin activity going on, and this basically proves that that the load balancer on the DMZ Edge is performing like it should by doing round-robin requests, forwarding requests to each respective web server, and then that web server talks to this load balancer. And this load balancer forwards the requests in round robin to the app servers, and then obviously the app server has configuration to forward to the database server. So this is basically our 3-tier application. So we just proven that routing from the external, from the data center side, has connectivity through the DMZ Edge, as well as through the internal DMZ, through the internal edge that traverses the transit logical switch. And we've proven that the VXLAN network works properly. What we could also do here now to prove some more is move the hosts around. So if I go to the compute, let's see, Web 01, where are you? It's on 4, and Web 02 is on 4. So let's move Web 01 to 05. Let's go to vMotion over. So now it's vMotioned. Let's go back to our app, and this should actually continue to work. There you go. Web 1 and Web 2 is still operational, still pulling requests from the database. So basically, what's happening here is that everything southbound of these edges, pretty much, is all VXLAN, all that communication. These virtual machines, they're connected to VXLAN logical switches. So there's VXLAN tunneling occurring between the server blades here, and all of that magic is occurring behind the scenes at the NSX layer. All right, so why don't we configure the distributed firewall here real quick to put the rules in that we were supposed to put in. So let's go to Network and Security and to the firewall.